Hey guys, it's Miss Johnson here, and I'm here to bring you your notes on 6.3, which is dividing polynomials. We're going to start off talking about dividing polynomials using long division, but also dividing monomials. So up at the top of your page, the first example says Ariana needs 140x squared plus 60x square inches of paper to make a book jacket for a book. It's 10x inches tall. In figuring the area she needed, she allowed for a front and back flap of the spine of the book jacket is 2x inches, and the front of the back book jacket are 6x inches. How wide are the front and the back flaps? Okay, so what we need to consider here is, first of all, how long is the book jacket? So if I am looking at this book jacket, I know that I've got a flap that's going to be F inches long on both the inside cover and the back cover, inside front and the inside back. But then I also know that the front cover is 6 inches, the spine is 2, and the back cover is 6x, all of those with an X. So altogether, this is 6, 12, 14x inches. Okay, and then I know that this is 10x inches. So what I have to consider is, this is my area, okay, and I know that area of a rectangle is equal to length times width. So if I want to get the width of the rectangle, or if I want to get the length of the rectangle because I'm given the width, that means I need to divide by width. So I'm going to take the area and I'm going to divide it by the width, which is 10x inches. So I've got 140, undo there, 140x squared plus 60x, and those are going to be divided by 10x inches. Well, when I divide by monomials here, I need to make sure that I divide each term by the denominator. So it's kind of like splitting that into two fractions. I have 140x squared divided by 10x, and I have 60x divided by 10x. And then I can simplify those. X squared over x, this 1x is going to cancel out, leaving you with a 1x left on the top, and 140 divided by 10 is 14. Over here in the second one, x over x is going to go away, and 60 divided by 10 is going to be 6. So that means that the total length of the book jacket is 14x plus 6 inches. Well, we know the 14x part. The 14x part comes from the spine and the front cover and the back cover. So that must mean that this 6 is for the two flaps. And since it's 6 for two flaps, I take 6 and divide it by 2 and get 3 inches for each side, for each flap. So I took the area, I divided it by the width, that gave me the total length, and then I got rid of the part I already knew and divided it by 2 because of the two flaps. Now, the whole point of that scenario is that we're talking about dividing a polynomial by a monomial. And when we divide a polynomial by a monomial, we just need to divide each term in the top, in the polynomial on top, by the monomial on the bottom. So if I take a look at example 1, I'm looking at 4x to the third plus 8x minus 12x squared, all divided by 4x. And I want to go ahead and split each of these and make them each divided by the denominator. So that's going to look like 4x to the third divided by 4x plus 8x divided by 4x minus 12x squared divided by 4x. And then I simplify that. 4 divided by 4 is going to go away. X to the third over x, I need to subtract those exponents, and this is going to go away. 3 minus 1 is 2, so I have x squared left over there. And then here in the middle term, 8 divided by 4 is 2. X over x goes away. I have nothing left in the denominator again, nothing left in the denominator there. Here, 12 divided by 4 is 3. Again, nothing left in the denominator. One of the x's is going to go away. I'm left with x to the second plus 2 minus 3x. Now I'll tell you, if this were an ACT or an MCA, you wouldn't see it in this order. You'd see it in standard form, x to the second minus 3x plus 2. That's how it would look in your answer choices. Let's take a look at number 2. In number 2, I have 16a to the 5th b to the 3rd plus 12a to the 3rd b to the 4th minus 28a b to the 5th all over a to the 4th b to the 3rd. So again, I need to split those. Each one is being divided by the bottom. So I have 16 a to the 5th b to the 3rd all over 8 a to the 4th b to the 3rd plus 12 a to the 3rd b to the 4th all over 8 a to the 4th b to the 3rd minus 20a b to the 5th all over 8a to the 4th b to the 3rd. So now let's simplify. 16 divided by 8 gives me 2. A to the 5th over a to the 4th, I can get rid of 4 of the a's, leaving me with 1 left on top. B to the 3rd over b to the 3rd, those are going to go away because it's a number divided by itself. Now, 12 can't be divided by 8 and leave you a whole number. However, 12 and 8 have a common factor, so I can take out the common factor there. I'd have 12 and 8 with a common factor of 4, meaning 12 divided by 4 gives me 3, and 8 divided by 4 gives me 2. Basically, we're just treating that as a fraction of 12 over 8 and reducing it by dividing each part by 4. That's all that really happened there, 3 over 2. So then the a's, I have 3 a's on top and 4 on the bottom. I can get rid of all 3 of these, and that leaves me with 1 on the bottom. And the b's, I have b to the 4th over b to the 3rd. Again, I can get rid of 3, but this time 3 on the bottom, leaving me with 1 on the top. Okay, let's look at the last term. 20 cannot divide by 8, same as 12 and 8, so I have to just take out the common factor, which again is 4. 20 divided by 4 is 5. 8 divided by 4 is 2. Then the a's. I have only 1 to get rid of because there's only 1 on the top. So I can get rid of that 1 on the top. That makes that a to the 3rd in the middle there. It's left on the bottom. B to the 5th over b to the 3rd. I can get rid of all 3 of these on the bottom, leaving me with 2 on the top. So now let's see if we can put it all back together. In here, in the first term, I got rid of the whole denominator. The only thing I have left on the top is a 2 and an a. Middle term, I have on the top 3 times b, and on the bottom 2 times a. And then in the last term, I have on the top minus 5 times b squared, and on the bottom 2 times a to the 3rd. Now it's really important here that you have kind of nice handwriting, because you can see when you start crossing stuff out, it gets kind of like a scribbly mess if you're not really careful about how it looks. Hopefully some of you have better handwriting than I do, so that'd be good. I want you to go ahead and pause the video at this point and see if you can work on number 3. So go ahead and grab that number 3 and do that one on your own. I want to move on and talk about long division here. Now, when we use long division to divide polynomials, now we're dividing by more than one thing. So those questions that we just looked at in numbers 1, 2, and 3, we were only dividing by a monomial. But here, now we're dividing by an actual polynomial. It happens to be a binomial here. We have 2 terms instead of just 1. So now we have to use long division. Now our long division setup is just like our long division setup was back in, I don't know, 3rd, 4th grade when you guys learned how to divide. I take the divisor and put it outside of the box, and I take the dividend, what I'm dividing, 2x to the 3rd plus 5x squared minus 2x minus 15, and that goes inside the box. Okay, so now I have my long division box set up, just like we had, again, back in like 2nd grade, 3rd grade, whenever you guys learned how to divide, it looks the same. And the process is kind of going to be the same. What you want to ask yourself is, if I look at just this 2x part, look at just the first term in the outside, 2x. What do I need to multiply 2x by to get to 2x to the third? Well, I would need an x squared because that would give me x to the third. So since it's an x squared, it's going to go above the x squared term. Okay, that's my first term in the answer. So then I multiply. X squared times 2x gives me 2x to the third. But I can't just multiply by the first term, I have to multiply by the second term as well. X squared times negative 3 gives me negative 3x. I'm going to subtract the whole thing. I highly recommend you put parentheses around it so you remind yourself, because the first two terms are going to drop out, which is what we want. The second two terms, you're now subtracting a negative, so you're actually adding a positive, and 5, this is a squared, by the way, sorry, x squared. 5x squared plus 3x squared is 8x squared. So be careful there, you're subtracting a negative, which turns into adding. So if I keep going here, now I need to ask myself the same question again. What do I need to multiply by? 2x to get to 8x squared. Well, 2 times 4 gives me 8, and x times x gives me x squared, so I need a 4x. So then I'm going to take that 4x and multiply. 4x times 2x is 8x squared. I need that next term to be dropped down, just like we would drop it down in the original type of division without any x's. And then 4x times negative 3 is negative 12x. And then I subtract. 8x squared minus 8x squared goes away. And then I have a negative 2 minus a negative 12, which is plus 12, and that gives me positive 10x. My next term needs to come down, so that's a negative 15. And I do it one more time. So now I have, what do I multiply 2x by to get to 10x? I need 5, just plain old 5, because I already have the x's there. So 5 times 2x gives me 10x. 5 times negative 3 gives me negative 15. And that looks pretty good, because what happens when I subtract here is 10x minus 10x is 0. Negative 15 minus negative 15, remember that's plus a positive, is going to give me 0 as well. So I have no remainder left over here, and this is my answer, my quotient. We're going to go ahead and stop the video at this point. Thanks for listening. Don't forget to hop back to Schoology and take that quiz, and I will see you all tomorrow.